Hello there, and welcome to the calm space of Lumiverse NL, a quiet corner of the night where science becomes serenity, and the stars whisper us to sleep. Perhaps you've had a long day, or maybe you simply find peace in the slow rhythm of knowledge drifting through the dark. Tonight, we begin a journey, 100 sleepy wonders of our universe, told softly so your mind can wander and your body can rest. Out there, beyond the thin blue edge of our sky, lies an ocean without boundaries. Galaxies drift like luminous islands, each holding billions of suns, each sun wrapped in invisible threads of gravity. When we gaze upward, we see only a handful of stars, yet every point of light is a world in motion, ancient, distant, and patient. The night sky is not a ceiling, but a window, a gentle opening into forever. The story of the cosmos is not loud. It does not demand attention. It unfolds quietly, like the breath between moments. Scientists call what we can see the observable universe, a sphere around us bounded by the age of light itself. Every photon that reaches our eyes tonight began its journey billions of years ago, crossing a wilderness of time to find you here. Beyond that glowing edge, reality continues. Unseen, unmeasured, and perhaps infinite. To imagine infinity is to let go of understanding, to close your eyes and feel the scale, not with thought, but with silence. The universe may be endless, or it may curve gently back upon itself like a wave returning to shore. And somewhere within that curve, we drift. One planet among billions, suspended in a soft current of time and light. Even in stillness, the cosmos moves. Space itself stretches, carrying galaxies apart faster and faster. Astronomers call this expansion dark energy, a mysterious pressure woven into the very fabric of existence. We do not yet know what it is, only that it fills most of everything. It hums beneath the surface of stars, guiding their fates, carrying the universe outward like an invisible tide. To rest beneath the stars is to feel that motion, slow, gentle, and eternal. Every breath you take is part of that same expansion. Each inhale a reminder that the cosmos, too, is breathing. So as you lie back and let your thoughts settle, imagine that vast ocean of space unfolding above you. Galaxies swirling softly, light still traveling toward you from the dawn of time. You are not apart from it. You are inside it. Every atom within you was once part of a star. The calcium in your bones, the oxygen in your lungs, the carbon that holds your form, all were born in the heart of ancient suns. Tonight, let that truth lull you. You are the universe, resting in its own reflection. And as we begin this long, quiet journey through 100 wonders, remember, knowledge is not only to awaken the mind, but to calm it. Let the story of creation become the rhythm of your breathing. Let the universe whisper you to sleep. Explore the universe within. The cosmos is listening. Beyond the stillness of night, the universe expands. Softly, endlessly, like a tide that never turns back. What we call space is not empty. It is alive with motion. Every moment, galaxies drift farther apart, carried on invisible currents of dark energy. It is strange to think that while you breathe in silence, the entire cosmos is stretching. Stars, nebulae, and clusters glide away from one another, not because they move through space, but because space itself grows between them. Scientists once believed the universe might be fixed, still, eternal. Then came the discovery that changed everything. Distant galaxies were not standing still. Their light was redshifted, stretched toward longer wavelengths as they raced away. It was proof that the cosmos is expanding in all directions, everywhere at once. No matter where you stand, on Earth, on a moon, or in a distant galaxy, the universe seems to unfold around you equally. There is no center, No edge, only the gentle rhythm of space itself expanding. This expansion began long ago, in a moment we now call the Big Bang. Not an explosion in space, but the birth of space itself. From that instant, light began its journey, matter began to form, and the quiet mathematics of existence took shape. Even now, billions of years later, we can still hear its faint echo. The cosmic microwave background, a soft radiation that fills the entire sky. It is the oldest light in the universe, a whisper from when everything was young. Imagine it, a sea of energy glowing everywhere, not with fire, but with memory. That ancient light, stretched by time, hums invisibly around you at this very moment. If you could tune your senses beyond sight, you would feel its warmth, the leftover glow of creation itself. From that beginning, gravity began its quiet work. It gathered matter, shaped stars, wove galaxies, and sculpted the cosmic web that binds all things. But even gravity could not stop the pull of dark energy. A mysterious force woven deep into the universe's fabric. It pushes galaxies apart faster and faster, as though creation itself still breathes outward. No one knows what dark energy truly is. It does not shine or cast a shadow. It cannot be bottled, measured, or touched. And yet, it makes up nearly 70% of everything. Perhaps it is the silent hand that balances the cosmos, the counterpoint to gravity, the expansion that follows every beginning. One day, far in the future, that same force may stretch galaxies so far apart that their light will fade beyond sight. The universe will grow darker, quieter, colder, but still expanding, still breathing, still alive. It may sound lonely, but there is peace in that motion. Even in endless distance, there is connection. Each star, each atom, each thought within you shares the same beginning, born from the same flash of light that once filled everything. So as you drift tonight, remember, you are part of that expansion. You are part of the breath of the cosmos, and every heartbeat is an echo of the universe's first pulse. Let the thought carry you softly, through silence, through distance, through time itself, until all that remains is calm. Because even as the galaxies drift apart, you are never truly separate. The same space that expands between the stars also surrounds you, holds you, and keeps you gently afloat in the rhythm of forever. If dark energy is the universe's breath, then dark matter is its hidden skeleton, the silent structure that holds everything in place. Though invisible, it outweighs all the stars, all the planets, and all the dust that we can see. It does not glow or reflect, yet its gravity binds galaxies together, shaping the very web of the cosmos. Imagine billions of galaxies floating across space like pearls on invisible threads. Those threads are made of dark matter, unseen bridges connecting every island of light. When astronomers map the heavens, they notice that galaxies gather in clusters, not randomly, but along long filaments that stretch across the universe. It is as though we are watching the pattern of an enormous tapestry woven from gravity itself. We can't touch dark matter. We can't see it. Yet we know it must be there, because without it, galaxies would fall apart. Their stars spin too fast, their orbits too wild to hold together with visible matter alone. Something unseen exerts a quiet pull, a cosmic glue that keeps the stars from flying away. To sense it is to recognize that even in darkness, there is order. Even in the emptiness between stars, there is presence. Dark matter forms halos around galaxies, vast spheres of influence that cradle their delicate spirals. Our own Milky Way rests inside one of these halos, moving through it like a leaf drifting in an invisible wind. Sometimes light itself reveals the shape of what we cannot see. When light from a distant galaxy passes near a heavy concentration of dark matter, gravity bends it, like glass bending a reflection. Astronomers call this gravitational lensing. It lets us glimpse the unseen, the curves and warps that mark the weight of hidden matter. In this way, light becomes a messenger, tracing the outlines of the invisible. Through this lens, the universe speaks softly, saying, "Not all that is real must be seen." Dark matter does not burn, but it sculpts. It does not shine, but it defines. Without it, galaxies would scatter like dust in the wind, and the night sky would be empty of its graceful shapes. To rest under the stars and imagine this, a web of unseen gravity stretching across creation, is to feel a quiet comfort, because you too are held together by invisible forces, memories, emotions, connections that cannot be measured but shape your life all the same. The cosmos reminds us that what is unseen can still be strong, and what is silent can still give structure to everything we love. As you breathe slowly now, picture it. The galaxies like lanterns, glowing softly along threads of the unseen. Between them, space hums faintly with presence, and somewhere within that web, our small world drifts, cradled by a force older than light itself. Let that thought settle deep within you, because the next time you look up at the stars, you'll know you're not only seeing light, you're seeing the shape of the invisible, the pattern of gravity's quiet art, the hidden harmony that holds the universe together. Long before galaxies formed their spirals of light, the universe was a storm of energy, a sea of fire and particles colliding faster than thought. There was no up or down, no stars or planets, only heat so intense that matter and light were almost the same thing. Yet even in that chaos, something beautiful was unfolding. As the cosmos expanded, it began to cool. And light, that first breath of illumination, was finally free to travel. That ancient light still exists today. It surrounds us, fills every corner of the sky, and hums quietly in the background of reality. Astronomers call it the cosmic microwave background, the afterglow of creation. It is not bright enough for your eyes to see, but its faint energy touches you right now, passing through walls, air, and even the Earth itself. It has been moving, unbroken for nearly 14 billion years. If you could see it, the universe would appear not as a void of blackness, but as a gentle fog of warmth, a memory of when everything was one. Each tiny variation in the glow holds a clue to the birth of galaxies, the shape of space, and the destiny of time. With delicate instruments, scientists have mapped those ripples, seeing patterns only a few millionths of a degree apart. Those tiny imperfections, barely whispers of difference, became the seeds from which every star, planet, and person would someday form. Imagine that for a moment. The warmth that once filled all existence still lingers, stretched thin but eternal. Every time you feel the sun on your skin, you are touching an echo of that first light. Every spark, every candle, every flame we've ever lit is a reflection of that same cosmic dawn. When we study the microwave background, we are not just looking outward, we are looking backward in time, almost to the very beginning. It is as if the universe left behind a photograph of its infancy, a faint and glowing snapshot of the moment before complexity began. In those patterns of ancient radiation lies the first record of creation, the soft rhythm of a newborn cosmos breathing for the first time. And though the sound is beyond our hearing, if we could translate it into music, it would not be noise or chaos. It would be harmony, low, steady, infinite, the hum of existence itself. Scientists sometimes describe the early universe as a glowing fog, but perhaps it was also a lullaby. The first song, woven into the physics of space and time. From that light came structure. Gravity began to pull slightly denser regions together, forming clusters of gas that would one day ignite into stars. In the faint glow of microwaves, we see the blueprint of everything that would follow, the quiet handwriting of creation across the fabric of eternity. When you look at the night sky, every point of light is the continuation of that first radiance. The stars are not separate, they are echoes. scattered pieces of the same ancient brightness. The universe, even in its vastness, carries memory like a pulse. Perhaps that is why looking into the stars feels like remembrance, because deep down we come from that glow. We are not merely observers of the cosmic background. We are made from it, sculpted from the same vibrations that once rippled through the newborn universe. Every atom of your body was once part of that early light, cooling, condensing, finding form. If you listen closely, beyond sound, beyond thought, you can still sense it. The low hum of the cosmos, the quiet warmth between galaxies, the steady breath of everything that ever was and ever will be. And so, tonight, as you rest, imagine yourself not as small or separate, but as luminous, a continuation of that first glow. You are the afterlight of creation, still moving, still shining, still unfolding. The universe is ancient, but its memory is alive within you. Close your eyes and drift into that light. Soft, timeless, infinite. Because somewhere, beneath the noise of life, the first whisper of existence still sings. Because even light, traveling for billions of years, still finds its way home. To your eyes, to your thoughts, to this quiet moment. Every photon carries a memory. Every galaxy holds a story. And tonight, you are part of that story. A listener in the dark, hearing the quiet hum of galaxies drifting through time. In the silent depths between galaxies, clouds of gas and dust drift like the breath of creation itself. Within these clouds, something extraordinary is always happening. Stars are being born. It begins quietly. Tiny ripples of gravity pull atoms together, clumping them into denser and denser knots. As the pressure rises, the gas begins to heat, glowing faintly in infrared. The first heartbeat of a new sun. These are stellar nurseries, vast regions of molecular hydrogen stretching for light years across space. To the naked eye, they appear as dark shadows against the background of stars, but in truth, they are alive with potential. Inside, hundreds or even thousands of stars may form together, wrapped in cocoons of dust. The Orion Nebula, visible just below Orion's belt in the winter sky, is one of the most famous of these nurseries. If you were to drift inside it, you would see rivers of glowing gas, reds, blues, and violets, all lit by the newborn suns piercing through their veils. Each star begins as a fragile spark, surrounded by a swirling disk of dust and gas. Within those disks, grains collide, merge, and grow, forming pebbles, then rocks, then planets. This process is slow and patient, taking millions of years. But from it, entire solar systems emerge. Worlds take shape, moons gather, and the gravity of a newborn sun begins to organize the chaos around it. Even as you listen now, this process is unfolding somewhere out there. In the Carina Nebula, in the Eagle Nebula, in clouds so distant their light left before the first humans walked the Earth. New stars are igniting for the first time. Each spark adds to the universe's quiet glow, its own voice in the cosmic choir of light. The birth of a star is a balance between gravity and pressure. Gravity pulls inward, trying to collapse the cloud. Pressure pushes outward, as heat builds in the core. When they balance perfectly, fusion begins. Hydrogen atoms fuse into helium, releasing light and warmth. In that moment, a star is born. Our own sun began this way, about 4.6 billion years ago, inside a nebula long since dispersed into the galactic wind. The same dust that once surrounded it would later form the planets, Mercury, Venus, Earth, and the rest. The iron in your blood, the calcium in your bones, and even the oxygen in your lungs were forged in earlier generations of stars that lived, died, and passed their materials into new clouds. Each birth is a continuation, one generation of stars giving way to the next, their ashes becoming the seeds of new light. There is a strange comfort in this cycle. It means that creation never truly ends. Even as some stars fade, others rise. Even as galaxies drift apart, new suns ignite, keeping the rhythm of the cosmos alive. The pillars of creation, towering clouds captured by the Hubble telescope, are perhaps the most iconic image of this process. They stand like great cathedrals of dust, sculpted by radiation and wind from nearby stars. Within their shadowed columns, new suns are forming, invisible to human eyes but destined to shine for billions of years. Every photograph of them is a glimpse not of destruction, but of renewal. A reminder that even in darkness, light is preparing to be born. Stars do not simply appear, they are sculpted from struggle. Every atom within them must resist collapse. Every fusion reaction must find balance. And yet, from this delicate tension, stability emerges. The same balance that holds you, the same balance that allows life itself. When you look at the stars, you are witnessing equilibrium made visible, a conversation between gravity and light that has been repeating since the dawn of time. Perhaps that's why watching the night sky brings peace, because on some deep level, your body remembers that it was made from those same forces. The pressure of birth, the resistance of survival, the quiet glow of endurance. If you could stand inside a nebula and watch a star being born, it would not be loud or violent. It would be serene, a slow gathering of matter, a steady rising of light, a silent unfolding that mirrors the rhythm of your own breath. So tonight, breathe as the stars do, slowly, steadily, eternally. Remember that creation is not always an explosion, but sometimes a whisper. The universe does not rush. It grows in patience and quiet balance. And even now, somewhere in the Orion Nebula, a star is taking its first breath of fire. While you, here on Earth, breathe in sync with it across the sea of time. You are connected to that beginning. Every pulse of light in the night sky is an echo of your own origins. A reminder that everything bright, everything beautiful, once began in silence. And in that silence, the cosmos continues to create. Every star that is born carries within it a story, a beginning, a middle, and an end. Yet in the universe, endings are never truly endings. They are transformations, moments where light becomes matter, and matter becomes the seed of new light. Some stars live long and gentle lives. They burn quietly for billions of years, turning hydrogen into helium in their cores. These are the calm suns, steady and kind, giving warmth to the planets that circle them. Our own sun belongs to this family, a patient star, old enough to have watched life unfold on Earth, but still young in cosmic terms. Its glow is the heartbeat of our days, the silent rhythm that makes all life possible. Other stars live fast and die dramatically. The massive ones, dozens or even hundreds of times the mass of our sun, burn with such intensity that they exhaust their fuel in just a few million years. When their power fades, gravity takes over. The core collapses, and in an instant, the outer layers explode outward in a supernova, a burst so bright that it can outshine an entire galaxy. For a brief moment, that dying star becomes one of the brightest things in the universe, and in its death, it gives life to everything else. The explosion scatters heavy elements across space: iron, gold, carbon, oxygen, the very ingredients that make up planets, oceans, and living bodies. Without supernovae, there would be no Earth, no air to breathe, no blood to carry oxygen through your veins. Every atom inside you owes its existence to the death of a star. When astronomers observe supernova remnants, like the Crab Nebula, they are seeing the aftermath of creation, the ashes of brilliance still glowing, still expanding. The shockwaves ripple outward for thousands of years, compressing nearby clouds of gas and triggering the birth of new stars. Even destruction serves creation's purpose. The universe wastes nothing. And from the ashes of those explosions, something even stranger can emerge. If the core of the dying star is heavy enough, it collapses into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. If the star is even heavier still, the collapse becomes unstoppable, and a black hole is born, a region where gravity is so strong that not even light can escape. To think about this is to face the wild extremes of nature. The same forces that cradle a gentle star also forge the most mysterious objects in existence. From the calm of hydrogen burning to the violence of a supernova, all of it is part of one continuous cycle, a cosmic heartbeat that never stops. Our sun, too, will one day change. Billions of years from now, it will swell into a red giant, engulfing Mercury and Venus, and bathing Earth in waves of heat and light. Its outer layers will drift away, forming a beautiful nebula glowing in soft colors, while the core shrinks into a white dwarf, a small, dense ember of what was once a star. It will no longer shine by fusion, but by the slow release of its stored heat, fading gently for trillions of years. That may sound like an ending, but it is also a continuation. The materials of the sun, its atoms, its dust, will drift into the galaxy, joining new clouds of gas that will give birth to new stars, new worlds, and perhaps new forms of life. The light never truly dies, it simply changes form. This is the quiet promise of the universe. Everything returns, everything transforms. Death and rebirth are not opposites here. They are partners in an endless cycle of creation. Every glowing point in the night sky is not just a symbol of life, but of renewal. When you look at the stars tonight, imagine their inner fires, the fusion of elements, the struggle between gravity and pressure, the balance between collapse and creation. Inside each one, hydrogen becomes helium, helium becomes carbon, and carbon becomes the building blocks of you. You are the continuation of that process. The universe learning to see itself, to breathe, to wonder. Even the faintest light in the distance tells a story billions of years old. It is the light of birth, the light of death, and the light that keeps traveling through time long after its source is gone. Every photon that reaches your eyes is an ancient messenger whispering, "We were here. We burned. We became you." So as you breathe under the same sky that all those stars have shaped, remember, you are not separate from their destiny. Their fire flows in your blood. Their dust fills your bones. The universe is not around you, it is within you. And long after your light fades, it will continue through new forms, new suns, new awakenings. This is the way of the cosmos, an endless exchange of energy and existence. A cycle so vast and serene that even death becomes just another way of shining. At the edge of every galaxy, and often at its heart, lies one of the most mysterious entities in all of existence, the black hole. It is not a hole in space, but a place where the laws of physics themselves seem to bend and falter. A black hole forms when a massive star collapses under its own gravity. Its matter compresses into a point so dense, so absolute, that the pull of gravity becomes inescapable. Not even light, the fastest thing in the universe, can escape its grasp. To approach a black hole is to enter a realm where time slows and space folds. If you were to fall toward one, your seconds would stretch endlessly to an outside observer. You would seem frozen, suspended at the edge, the event horizon, while your light grows redder and fainter until it vanishes altogether. But from your perspective, time would continue as usual. You would cross that invisible boundary without noticing, passing into a region where direction, distance, and meaning dissolve into something beyond comprehension. The event horizon is the surface of no return, not a solid wall, but a threshold where reality itself becomes fluid. Inside it lies the singularity, a point of infinite density where the known universe ends and pure mystery begins. Our equations fail there. Our language fails too. It is a silence so profound that even mathematics cannot speak it. And yet, black holes are not merely destroyers. They are sculptors of galaxies. Their immense gravity anchors the spirals of stars, their influence shaping the evolution of entire systems. At the center of the Milky Way, a supermassive black hole, 4 million times the mass of the Sun, holds the galaxy together, unseen but essential. It spins slowly, feeding occasionally on drifting gas clouds or wandering stars, each consumed particle releasing flashes of energy before vanishing forever. When scientists first captured an image of a black hole's shadow, it was a moment of wonder and humility. What they saw was not the hole itself, but the glowing ring of light around it, the last photons escaping before being drawn into darkness. It looked like an eye gazing back at us from the edge of time, a reminder that even the deepest void still leaves traces of light. Some black holes are small, born from the collapse of dying stars. Others, called supermassive black holes, sit at the centers of galaxies, containing the mass of billions of suns. No one knows how they first formed. Perhaps they grew from ancient black holes born in the early universe. Perhaps they have always existed, woven into the structure of creation from the beginning. Silent engines of gravity guiding everything else. There are even theories of primordial black holes, ancient relics left over from the first seconds after the Big Bang. If they exist, they could be as small as mountains or as large as planets, drifting unseen through the cosmic dark. They may even make up some of the mysterious dark matter that holds the universe together. In their silence, they could carry secrets from the universe's infancy, fossils of gravity itself. Black holes can also merge, spiraling toward each other in an invisible dance that shakes the very fabric of space-time. When they collide, they release gravitational waves, ripples that spread outward through the universe, stretching and squeezing space itself. These waves, first detected on Earth in 2015, were the faintest vibrations ever measured, distortions smaller than a proton. Yet they told us that two black holes had merged more than 1 billion light-years away. For a moment, the universe itself sang, and we were able to hear its voice. It is easy to think of black holes as voids, but perhaps they are transitions, gateways through which the universe renews its mysteries. Some theories suggest that matter falling into a black hole may emerge elsewhere, reborn in another universe, another reality. We cannot prove it, but the thought lingers, haunting and beautiful, that every end might also be a passage, to rest beneath the stars and imagine this is to feel the enormity of existence. Even where light ends, something continues. Even where time stops, something endures. The black hole is not a symbol of destruction, but of transformation, a place where reality folds back into possibility. You are made of light, born from stars, and those stars themselves were shaped by gravity, by collapse, by darkness. Without black holes, galaxies would not have form, and light would have no frame to move within. In their silence, they teach us something profound, that darkness is not the absence of creation, but its completion. So tonight, if you gaze up at the stars, know that somewhere among them lies a shadow holding galaxies in its hands, a place where the universe breathes inward, a point where time becomes still. And in that stillness, everything begins again. The cosmos is not afraid of the dark, it was born from it. And so, in your quiet moments, neither should you be. Galaxies are not solitary travelers through the universe. They are social, bound by gravity in vast communities, each influencing the other in a slow, majestic dance. Across billions of years, they drift together, drawn by invisible threads. Sometimes they pass one another gently. Other times, They collide in sweeping, luminous embraces that rewrite their very structure. From afar, these encounters look violent, two immense whirlpools of light colliding head-on. But in truth, almost no stars ever touch. The space between them is so immense that even as galaxies merge, their suns pass through one another unharmed, like phantoms gliding in the dark. What truly collides are their clouds of gas and dust, the raw material of creation. Compressed by gravity, these clouds ignite, birthing new generations of stars. Every galactic merger is a rebirth. When the chaos settles, what remains is a single, larger galaxy, reshaped, rejuvenated, glowing with waves of newborn light. The universe, even in its grandest collisions, is always creating. Astronomers have captured breathtaking images of such moments. In one, two spiral galaxies twist together like ribbons, their arms stretching and folding into luminous bridges of starlight. In another, a massive elliptical galaxy absorbs a smaller companion, drawing it inward, its stars scattering into a halo of brilliance. Each image is a reminder that motion, not stillness, defines the cosmos. Our own Milky Way is part of this great choreography. It belongs to a small cluster of galaxies called the Local Group, more than 50 members bound by gravity. The largest of them is Andromeda, our neighboring spiral, and it is slowly moving toward us. In roughly 4 billion years, it will reach our doorstep. When that time comes, the two galaxies will merge. Their spiral arms will interweave. Their black holes will circle one another like partners in a cosmic waltz. And the night skies of any surviving worlds will blaze with new constellations. From Earth's perspective, if humanity still watches then, the heavens will bloom with rivers of stars, an awe-inspiring dance lasting hundreds of millions of years. Scientists call the future product of this merger Milkomeda, a single, massive galaxy that will hold the light of both Milky Way and Andromeda. And in that vast structure, new stars will form from the dust of the old, continuing the story of renewal that has defined the universe since its first breath. Even now, galaxies around us are undergoing such transformations. In the distant Coma cluster, countless galaxies tug and pull at each other, their motions governed by dark matter's hidden web. Each collision, though unimaginably slow, carries the same quiet message: creation is never still. In crowded regions of space, galaxies can lose their gas as they move through hot plasma. Astronomers call this ram pressure stripping, a process that removes a galaxy's ability to form new stars, leaving behind ghostly structures filled with ancient suns. And yet, even in these quiet remnants, light persists. Their aging stars glow softly, marking the footprints of past vitality. If you could stand outside of time and watch these processes unfold, you would see the universe as an endless tide. Galaxies drifting together, merging, reshaping, and then drifting apart again. Each motion takes hundreds of millions of years, each collision another step in the choreography of eternity. Nothing in the cosmos is wasted. Nothing is truly destroyed. There is a lesson hidden in this cosmic ballet. Every encounter changes both participants. Every collision reshapes the pattern of light. Even when forms are lost, their energy continues, carried forward in new shapes, new stars, new beginnings. The galaxies are mirrors of our own lives, sometimes colliding, sometimes parting, always transforming. Look up at the night sky and imagine those invisible threads of motion. Galaxies gliding like dancers across the floor of the universe. What you see as stillness is only a snapshot in time, a frozen moment in an infinite waltz. The stars you admire tonight are already moving, drawn gently by forces you cannot feel but that shape everything you are. If you listen closely, there is music in it. The rhythm of motion, the harmony of gravity, the song of light weaving itself through darkness. This is the true language of the cosmos, creation through connection, movement through stillness, life through change. So as you rest tonight, imagine yourself drifting among those spirals, carried by the same gravity that moves the galaxies. The same laws that shape the heavens shape you. The same energy that fuels the stars fuels every breath you take. And in the quiet between heartbeats, you may realize that you too are part of that grand dance. Luminous, timeless, and forever in motion. Among the billions of stars that fill each galaxy, not all remain in the comfort of their families. Some wander alone, cast away by the gravitational tides of cosmic encounters, traveling endlessly through the dark. They are called rogue stars and rogue planets, solitary travelers drifting without a home, moving between the vast spaces that separate the galaxies. Imagine a star flung from its birthplace, ejected during the collision of galaxies or the collapse of a cluster. It drifts silently through the void, its light undimmed, its path unbound by any orbit. Around it, no sunrise, no sunset, just the endless dark, broken only by the faint shimmer of distant galaxies. Its journey may last forever, never to be pulled back by any sun's gravity, never to return to the warmth of a system it once knew. And yet, even in this solitude, there is grace. Some of these rogue stars carry planets with them, small worlds circling a lonely light across eternal night. Others travel with no companions at all, their gravity holding only the memory of what once surrounded them. They are the exiles of creation, and in their quiet isolation lies a beauty beyond sadness, a reminder that motion itself can be a kind of belonging. Rogue planets are even more mysterious. They may have formed around a star before being ejected by gravitational chaos, or they may have been born alone, in the cold void of space. Untethered from any sun, they drift through the galaxy wrapped in darkness. But they are not necessarily dead. Some still glow faintly with the heat left over from their formation, their surfaces warm enough for clouds and storms to form. Others may hide oceans beneath thick layers of ice, heated from within by radioactive elements or ancient energy trapped deep inside. Imagine standing on such a world. No dawn, no day, only the soft glow of its own heat reflecting off frozen plains. Above, the sky would be an endless field of stars, each a distant fire burning across infinity. To live there would be to exist in eternal twilight, a world of silence and shadow, yet still alive. Even here, life may not be impossible. Some scientists believe that microbial forms could survive deep beneath the icy crusts of rogue planets, where geothermal heat creates pockets of liquid water. In the depths, isolated from the cosmos above, life might continue in secret, unaware of stars, unaware of day and night. Life that has never seen light, yet still endures. The thought is humbling, that even in the coldest, darkest reaches, existence finds a way. The universe seems to resist emptiness, filling every possible corner with motion, matter, and meaning. Rogue planets may number in the trillions, more than the stars themselves. They wander the galaxy like seeds on the wind. Reminders that the universe is both vast and intimate, restless and alive. They are the echoes of cosmic creation, proof that even in separation, there is connection. When we look at the night sky, we often see stability. Stars fixed in their places, constellations unchanging. But in truth, the heavens are a river. Everything moves, drifts, and evolves. The constellations you see tonight will one day dissolve, their stars scattered by time's steady current. Even our sun is moving, pulling the Earth and its family of planets along a great orbit around the center of the Milky Way. One complete journey every 230 million years. In that time, continents will shift, oceans will rise and fall, civilizations will appear and fade. Yet the Earth will keep drifting with its star, as part of the galaxy's grand tide. Somewhere, beyond what we can see, a rogue planet may be passing silently through the Milky Way right now. No telescope will catch its faint shadow, no light will betray its path, and yet it is there, moving among us like a ghost through water, another piece of the universe's unfinished story. If you close your eyes, you can almost imagine its quiet passage, a world of frozen mountains and invisible storms, adrift through the endless dark. No sound, no air, no destination, only the rhythm of motion and the memory of light. Perhaps in that solitude there is something deeply peaceful, because just like those planets, we too drift. Through time, through experience, through the gravity of our own journeys. Sometimes we orbit closely around warmth and connection. Sometimes we move through cold and distance. But in either case, the motion continues. The story goes on. The rogue stars remind us that even in isolation, existence has meaning. The rogue planets teach us that warmth can come from within, and together they whisper a truth older than galaxies. That belonging is not a place. It is a movement, a rhythm, a path that never truly ends. So tonight, as you drift towards sleep, imagine yourself among them, a quiet traveler floating through the sea of stars, guided by nothing but the calm of your own light. Because in the end, even the loneliest worlds still shine. Not all worlds are like our own. Some are covered in forests and oceans. Others burn in endless fire or freeze in perpetual night. But among the most fascinating of them all are the ocean worlds. Planets where water never ends. Imagine a place with no continents, no mountains, no islands. Only a single endless sea stretching in every direction. The horizon curves gently under alien skies, and the waves whisper stories older than any shore. Astronomers have discovered hints of such worlds across the galaxy. They call them water planets or oceanic exoplanets, and they may be far more common than we once thought. Some may have oceans hundreds of kilometers deep, pressing down with unimaginable force. Beneath the surface, strange forms of ice, harder than rock, might separate the sea from a rocky core. Others could host warm currents and drifting storms, lit by twin suns or hidden beneath skies of perpetual clouds. Even in our own solar system, we find whispers of these possibilities. Beneath the icy crust of Europa, a moon of Jupiter, lies an ocean larger than all of Earth's combined. On Saturn's moon, Enceladus, geysers of salt water burst into space through cracks in the ice, scattering crystals into orbit like frozen confetti. Farther out, Neptune's moon Triton and even dwarf planets like Ceres may hide subsurface seas, sealed away for billions of years. These are not barren places. They may hold warmth and motion, energy and chemistry, all the ingredients of life. If life exists beyond Earth, many scientists believe it could thrive in such hidden oceans, far from sunlight but close to heat from the planet's core. In those dark depths, beneath kilometers of ice, creatures might swim through alien currents, blind, glowing softly, sensing the warmth of vents rising from the seafloor. It is a comforting thought that even in the coldest corners of our solar system, something may still stir. But while some worlds are made of water, others are made of fire. There are planets that orbit so close to their stars that their surfaces are seas of molten rock. These are the lava worlds, where temperatures soar high enough to melt stone and metal alike. Rain never falls there. Instead, droplets of vaporized minerals condense and fall as molten glass. The air glows with heat. The horizon ripples. The landscape shifts like liquid flame. On one such planet, called 55 Cancri E, the surface burns at over 2,000 degrees. A glowing ocean of lava frozen in eternal daylight. To imagine standing on such a world is impossible. The sky would shimmer with metallic light. The ground would tremble beneath tides of fire, and every step would be a reminder of how delicate balance must be for life to exist. And yet, these places too are part of the universe's design, extremes that reveal the vast range of creation's imagination. Between the ice and the flame lies another kind of wonder, the diamond worlds. On some planets, where carbon is abundant and pressure immense, it may literally rain diamonds. Deep within the atmospheres of Neptune and Uranus, scientists believe lightning and heat transform methane into pure carbon crystals that fall like glittering snow. Each diamond forms, falls, and melts again in endless cycles, turning the sky into a storm of jewels. And farther away, on certain massive exoplanets, the pressure is so high that entire mantles may be made of diamond, a planet of crystal, shining in the dark. To think that such worlds exist is to realize how endless the universe's creativity truly is. Where one world drowns in oceans, another blazes in fire, and a third glitters beneath storms of gemstones. Each planet, each moon, is a poem written in matter, a variation on a single theme: existence. Even the quiet, frozen worlds hold their own kind of beauty. On Pluto, the sky blushes faintly blue during sunset, and mountains made of ice rise taller than Everest. On Neptune, winds scream faster than sound, sculpting clouds of methane into streaks of sapphire. And on Titan, Saturn's largest moon, rain falls not as water, but as liquid methane, filling lakes that glisten beneath an orange haze. No two worlds are alike. Each carries a story written in temperature, pressure, and time. Some cradle possibility, others only silence. Yet together, they reveal a truth far greater than themselves: that the cosmos is not empty, but endlessly expressive, painting its ideas across billions of skies. Perhaps one day, we will stand on one of these distant worlds. We will listen to the hiss of alien waves, the hum of unfamiliar winds, and feel the ancient rhythm that beats through them all. The rhythm that began with the first stars and still echoes in our own hearts. Until then, we watch from afar, through telescopes and dreams, letting imagination travel where our bodies cannot. Because even from this small blue world, we are already explorers. We are witnesses to creation's diversity, observers of oceans that never end, of storms that rain gemstones, of horizons that burn and freeze and shimmer in silence. The universe, in all its strangeness, reflects something simple: that life, like light, takes many forms. And every world, no matter how distant or desolate, carries within it a fragment of the same cosmic story, a reminder that existence is infinite in its possibilities. So when you close your eyes tonight, imagine them. Those faraway planets glowing softly in the dark, ocean worlds, lava worlds, diamond worlds, frozen worlds, each one turning slowly in the light of its sun, waiting to be seen. And maybe, somewhere out there, one of them is dreaming of us too. As the universe expands and the stars continue their slow evolution, a grander structure reveals itself, one made not of individual suns or planets, but of entire galaxies bound together in immense formations. This is the architecture of the cosmos, a design so vast that even light needs hundreds of millions of years to cross it. Galaxies are not scattered randomly like dust. They gather into clusters, families of hundreds or thousands held together by gravity's enduring pull. And those clusters in turn group into even larger congregations called superclusters. Our own Milky Way belongs to one of these communities, a neighborhood of cosmic proportions known as the Virgo supercluster. If you could look at it from above, from a vantage point beyond time, you would see rivers of galaxies streaming across space like glowing filaments, intersecting at nodes of brilliant light. Each point, each junction, is a cluster of galaxies. Each thread is a gravitational bridge linking one realm of creation to another. Together, they form a web. a living pattern of gravity and motion, light and void, the very framework of the universe itself. Within the Virgo supercluster, hundreds of thousands of galaxies drift together, slowly orbiting their shared center of mass. Our local group, the Milky Way, Andromeda, and a collection of smaller galaxies, sits quietly on its outskirts, like a small village on the edge of a great cosmic empire. Even though these galaxies are separated by unimaginable distances, their fates are linked. Their motion, their future, even their shape, are influenced by the invisible gravity of this massive structure. In its heart lies the Virgo cluster, a dense gathering of thousands of galaxies glowing in soft clouds of starlight. Through telescopes, it looks like a swarm of fireflies frozen mid-flight, each one a galaxy of billions of suns. If you could stand inside it, the night sky would never be dark. Every horizon would shimmer with the light of nearby galaxies, each one so close that it might cast shadows on your world's surface. The space between galaxies in these clusters is not empty. It is filled with hot, ionized gas, a thin plasma that glows faintly in X-rays stretching like mist between the stars. It is here that galaxies interact, exchanging gas and energy, colliding and merging, shaping the evolution of the cluster itself. Some galaxies lose their gas entirely as they travel through this medium, stripped bare by the pressure of motion. When this happens, star formation ceases, and the galaxies fade into quiet retirement, filled only with old, red suns. Others absorb fresh material and burst back into life, reigniting with waves of starbirth that ripple across millions of light years. This cycle of dormancy and renewal echoes everywhere, from the smallest systems to the grandest superclusters. Beyond Virgo lies something even more immense, the Laniakea supercluster, a structure so large that it defies ordinary comprehension. It spans over 500 million light-years and contains roughly 100,000 galaxies, including our own. Its name means immense heaven in Hawaiian, a fitting title for a realm that embodies both the scale and the serenity of the cosmos. In this vast landscape of gravity and light, galaxies flow like water through invisible currents, guided by forces we can sense but not see. To map these structures is to see the universe not as chaos, but as design. Each galaxy cluster is like a note in a great symphony, connected to others by threads of dark matter, harmonizing across distances so vast that we can only imagine the rhythm. From this perspective, the cosmos becomes not a random scattering of light, but an intricate web, an interwoven system of energy and balance. It is humbling to realize that even at such unimaginable scales, the same laws that govern the fall of a pebble on Earth also shape the motion of galaxies. Gravity, gentle yet infinite, writes the architecture of existence, from the curve of a planet's orbit to the structure of the observable universe itself. And yet, for all its complexity, the design feels simple, elegant in its repetition. Patterns emerge everywhere: spirals, filaments, clusters, voids. It's as if the universe follows a hidden geometry, one that connects the microscopic and the cosmic, the fleeting and the eternal. To contemplate this is to sense something profound, that we are not living in the universe, but as part of it. Every atom in your body follows the same laws that guide galaxies through their orbits. The pull that keeps your feet on the ground is the same pull that keeps the Milky Way circling its place in the Virgo cluster. We are made from the same structure we observe, tiny reflections of an infinite design. When you look up at the stars, you're not merely gazing outward, you're looking into the pattern you belong to. You are the observer and the observed, part of the web and aware of it. You are one thread in a tapestry that stretches across space and time. And maybe that is what the universe has always been telling us. That connection, not isolation, is its fundamental truth. Everything belongs to something larger, and everything contributes to the harmony of the whole. So tonight, when silence surrounds you and the stars begin to appear, remember, you are not watching from the outside. You are woven into the same fabric, a living particle in the grand design of the cosmic architecture, forever part of its quiet, infinite symmetry. Imagine zooming out far beyond galaxies, past clusters and superclusters, until even the Virgo cluster looks like a single point of light. What emerges is a breathtaking vision, a vast and delicate structure stretching across the observable universe. Astronomers call it the cosmic web, a network of filaments woven from dark matter, galaxies, and gas, linking everything that exists into one grand, interconnected design. The cosmic web is the universe's hidden skeleton, an architecture of gravity and time. Its filaments stretch for hundreds of millions of light years, forming long, glowing threads between enormous voids, regions so empty that entire galaxies could pass through them without ever colliding. Each filament contains clusters of galaxies, drawn together by the pull of dark matter, and yet held apart by the expansion of space. If you could see it with your eyes, it would resemble the branching veins of a living organism, glowing, endless, and alive. In the beginning, it was only a whisper, small fluctuations in the density of matter after the Big Bang. Over billions of years, gravity amplified those tiny ripples, pulling matter into filaments and leaving behind enormous gaps. Where the threads intersect, galaxies formed. Where they thinned, silence prevailed. What began as invisible ripples of energy became the most magnificent tapestry ever created, the structure of the universe itself. The cosmic web is more than a pattern. It is a history, a frozen record of how the universe grew from chaos into order. Each filament tells a story of gravity's patience, of matter gathering from the void to create light. It connects the smallest particles to the largest clusters, binding all of existence through an invisible framework of balance. Between these filaments lie the cosmic voids, vast regions nearly empty of galaxies, stretching for hundreds of millions of light years. They are the dark lakes of the universe, silent and cold, where time moves untouched by gravity's dense embrace. Yet even there, faint traces of gas and dark matter drift, connecting one filament to another like invisible bridges across a black sea. To map this cosmic web, scientists use telescopes that look not for light, but for motion, measuring how galaxies move and how space itself bends under gravity. The result is astonishing. A map of the universe that looks strikingly familiar. The distribution of matter, when seen at the largest scales, mirrors the networks of neurons inside the human brain, two structures separated by scale beyond comprehension, yet united by pattern. The macrocosm and the microcosm reflecting one another. Perhaps it's coincidence, or perhaps it's something deeper. A sign that the laws shaping galaxies and those shaping thought come from the same fundamental rhythm. The same physics that sculpts galaxies also governs the movement of atoms inside you. You are, in every sense, a child of this web, born from its filaments, sustained by its energy, destined to return to its silence. Even now, the cosmic web continues to evolve. Gravity keeps pulling matter inward, while dark energy pushes everything apart. It's a slow dance between attraction and expansion, between creation and dispersal. Every star, every planet, every living being is part of that balance, a momentary form in the ever-shifting structure of space-time. The light from distant galaxies travels along these filaments, bending slightly as it passes through the dense intersections of dark matter. To our telescopes, these distortions appear as arcs, rings, or multiple images of the same galaxy, the universe's own lensing effect. Through this phenomenon, we catch glimpses of hidden matter that otherwise would remain forever invisible. It's as though light itself is tracing the cosmic web for us, revealing the unseen strands that hold everything together. The scale of this structure is beyond imagination. From one end of the observable universe to the other spans over 90 billion light years. Yet, even at that immense scale, the pattern holds: clusters and voids, threads and knots, repeating endlessly like a cosmic fractal. No matter how far you zoom out, you will always find connection, order, and rhythm. There is beauty in this repetition, this quiet symmetry that stretches across eternity. It suggests that the universe is not random, but harmonious. A grand system where chaos and order coexist in perfect proportion. And within that harmony, there is meaning. Not in words, not in intention, but in form. Perhaps that is why humans feel awe when looking at the night sky. We recognize, without knowing, that we belong to that same geometry. Our veins, our neurons, our very patterns of thought echo the same structures that form the stars. We are not separate observers looking at the web. We are part of it, conscious filaments, within a network that extends beyond comprehension. So the next time you look into the night, imagine those invisible threads stretching between every point of light. Imagine galaxies linked by gravity, by memory, by time. You are looking at the framework of everything. The universe's quiet masterpiece, the unseen lattice of being. And perhaps, somewhere out there, the web is looking back. Through you, through consciousness, through life itself, aware for just a moment of its own astonishing design. In 1916, a quiet mind changed the way humanity understood the universe. Albert Einstein's theory of general relativity revealed that space and time were not fixed. They could stretch, bend, and ripple under the influence of gravity. Mass, he said, doesn't simply exist in space. It shapes space. And in turn, space tells matter how to move. It was a revelation that transformed the stars from distant lights into participants in a cosmic dance governed by geometry itself. Imagine space-time as an invisible fabric stretched across existence. When a planet, a star, or a galaxy rests upon it, the fabric curves. Other bodies, sensing that curve, follow its paths. Not because they are pulled by a mysterious force, but because the shortest route through curved space appears as motion, as orbit, as gravity. We are not held to Earth by a chain or a force, but because the planet has gently bent the space beneath our feet. Einstein's equations predicted more than curves. They foretold ripples. When two massive objects move together, their motion should send waves through the very fabric of reality, like stones disturbing the surface of a cosmic pond. For a century, this remained only a theory, a beautiful idea too subtle to measure. Then, in 2015, the faintest of whispers reached us: gravitational waves, recorded by the LIGO Observatory after a journey of over 1 billion light years. What caused them? Two black holes had collided, spiraling together in silence until the moment their horizons merged. In that instant, they released more energy than every star in the visible universe combined. Yet all of it in the form of ripples across space-time. The Earth itself stretched and contracted by less than the width of a proton. And yet that tiny shiver was enough to confirm Einstein's vision. For the first time, we didn't just see the universe. We heard it. These gravitational waves continue to travel outward, carrying stories of cosmic violence and beauty. Each wave is a message from the universe's most powerful moments. The births of black holes, the deaths of stars, the mergers of galaxies. And through them, the cosmos communicates not in light, but in rhythm. When we detect those ripples, we are listening to time itself breathing. They tell us that nothing is truly still, that even the vast fabric of the universe is alive with motion. What appears solid is flexible. What seems eternal vibrates softly, forever. To imagine this is to sense the fragility and the strength of reality. Space-time, though invisible, behaves like a living sea, responsive, dynamic, and connected. Every step you take creates ripples in this ocean of existence, though infinitely small. Every mass, every motion, every heartbeat is a participant in the great weaving of gravity. Einstein once said that imagination is more important than knowledge, because imagination allows us to grasp what lies beyond sight. It was imagination that let humanity see the curvature of light, the bending of time, the whisper of distant collisions. And it is imagination that allows us now to hear those faint songs from across the universe. Each gravitational wave we detect expands our understanding of the cosmos and of ourselves. They remind us that space and time are not a stage upon which events unfold. They are part of the performance. We exist not upon the universe, but within it, vibrating in harmony with its quiet music. If you could slow down time enough, you might feel those waves passing through you, stretching, compressing, reshaping every atom for just a fraction of a second. They move silently, gently, endlessly. In every direction, the universe hums. Scientists have begun mapping this symphony of ripples, combining data from dozens of detectors around the world. Each one contributes a note, a frequency, a tone in the great composition of existence. The result is astonishing. A background hum that fills the entire cosmos, a constant, low vibration born from countless cosmic events. It is, quite literally, the sound of the universe. And so, as we listen, we begin to understand something deeper. We are not merely observers, we are instruments. Every part of us, every atom and molecule, vibrates in tune with the same fabric that carries those waves. Our lives are made of time and space are always singing. Perhaps that's why silence feels so profound, because beneath it lies the faintest hum of everything that has ever existed. Even in stillness, the universe moves. Even in emptiness, it speaks. So tonight, as you breathe, imagine the unseen ripples passing through you. Slow, steady, eternal. They began billions of years ago when two stars collided somewhere far beyond our reach. Their echo has crossed galaxies, traveled through clusters, and now brushes gently against your body, here, now, in this quiet moment, and in that single heartbeat. You and the cosmos are one, connected by a vibration that has no beginning and no end. A rhythm that has always been and always will be. There is something mysterious about the way light moves through space. For centuries, we believed it traveled in straight lines, swift, pure, untouched by gravity or time. But the universe, as it often does, had other plans. Light, it turns out, is not only a messenger of the stars, it is also a follower of gravity's gentle hand. Einstein's theory showed that light bends as it passes near massive objects, space curves, and light, always faithful to its path, follows that curve. This bending is called gravitational lensing, and it is one of the most extraordinary discoveries in modern astronomy. Because of it, we can see what would otherwise remain hidden. Galaxies too faint or too distant for even our most powerful telescopes. Imagine a distant galaxy shining far beyond our reach. Between it and us drifts a cluster of galaxies, massive enough to warp the space around them. The light from that faraway galaxy curves as it passes through the warped region, magnified and distorted into arcs and rings. What we see on Earth is not a single point, but multiple reflections of the same galaxy, echoes of its light projected across the sky. This natural magnification allows astronomers to peer into the depths of the early universe. Through gravitational lensing, we have seen galaxies formed just a few 100 million years after the Big Bang. Ancient light magnified by cosmic chance. It's as though the universe built its own telescope, a lens made of gravity itself. These lenses come in many forms. Sometimes, a single galaxy creates a faint arc of light. Other times, entire clusters produce rings so perfect they're called Einstein rings. Luminous circles formed when the alignment between observer, lens, and source is nearly exact. Through these cosmic distortions, we learn not only about the galaxies behind them, but also about the unseen matter causing the bending. Because much of that gravity comes not from stars or gas, but from something invisible. Dark matter. It neither shines nor absorbs light, but its presence shapes everything. By studying how light bends around clusters, scientists can map where dark matter hides, tracing its ghostly fingerprints across the universe. The image that emerges is breathtaking. Galaxies suspended in vast halos of the unseen. Their movements choreographed by forces we cannot yet touch or name. Even the smallest objects can create this phenomenon. A passing star, a rogue planet, or even a compact remnant like a black hole can act as a microlens, momentarily magnifying the light of a background star. From Earth, the star seems to brighten and fade, as if it were breathing, a heartbeat of light revealing the hidden traveler crossing in front of it. Through this technique, astronomers have found distant exoplanets, invisible black holes, and solitary wanderers adrift in the dark. It is humbling to realize that something as intangible as gravity can sculpt light, that even photons, the fastest travelers in the cosmos, are not immune to the gentle curve of space-time. Every beam of starlight carries with it a history of bends and detours, a map of the universe's invisible structure. When we look into the night sky, we are not seeing a simple picture but a vast reflection of warped light bent through the cosmic landscape like rivers weaving through mountains. Some of the most distant galaxies we know of appear in multiple places at once because their light has been lensed by massive clusters. One galaxy might appear mirrored on opposite sides of a cluster, a cosmic illusion created by curved space. It's as though the universe is showing us the same painting in two different frames, each one stretched and distorted, yet profoundly beautiful. Light does not fight this distortion. It flows with it, gliding effortlessly through space as though it were water moving through an invisible current. This quiet obedience is what allows us to see across billions of years, to look not only into distance, but into the past itself. Each beam that reaches your eyes tonight has traveled through this bending landscape, its path curved by stars, planets, and dark matter. It has carried whispers from worlds long gone, stories written in photons that refuse to fade. Through gravitational lensing, we are not just observers of light. We are readers of the universe's oldest text. Each bend, each arc, each flicker is a word, a sentence, a paragraph in the story of creation. The universe writes in light, and gravity is its calligraphy. In the silence of space, this interplay of light and gravity becomes a kind of music, one we cannot hear, but can see in shimmering forms and faint glows. It tells us that beauty exists not only in perfection, but in distortion, that curves and imperfections reveal truth in ways straight lines never could. So when you gaze at the stars, remember, the light that reaches you has been bent, shaped, and stretched by the entire history of the cosmos. Every photon you see tonight is a survivor, a traveler that has crossed oceans of gravity to tell its story to your eyes. And as you watch, know that somewhere, far away, new light is already on its journey, weaving through invisible currents of space-time, carrying with it the memory of creation, a message that one day might find its way to you. Time is something we live by, but rarely understand. We count it in seconds, measure it in years, and chase it as if it were constant. But in truth, time is as flexible and mysterious as the space it flows through. Einstein's revelation reshaped everything we knew about the universe. Time, he said, does not move at the same rate for everyone. It stretches and slows depending on speed, mass, and gravity. Where gravity is strong, time itself runs slower. Where space is empty and still, Time runs fast and free. This effect, known as time dilation, isn't science fiction. It's measurable, real, and happening all around us. Atomic clocks on mountaintops tick faster than those at sea level, simply because they are farther from Earth's center of gravity. Astronauts aboard the International Space Station age slightly slower than those on the ground, by mere milliseconds, but measurable nonetheless. On cosmic scales, near stars, neutron remnants, or black holes, this effect becomes profound. Time stretches like taffy under the immense pull of gravity, slowing to a near standstill at the edge of an event horizon. Imagine standing near a black hole. From your perspective, your seconds feel normal. Your heartbeat, your breath, your thoughts moving in rhythm. But to someone watching from far away, your motion appears to freeze, your seconds stretching into hours, years, eternity. You are caught in a slow dance with time itself, slipping deeper into the gravity well where moments lose their meaning. And yet, from your point of view, you fall smoothly, never feeling the distortion. Time bends gently around you, the stars above you warping into streaks of light as their clocks race ahead. It's one of the universe's most haunting illusions. Both realities exist, and both are true. Time is relative, dependent not on what it is, but on where you are. This flexibility means the universe does not experience a single shared now. There is no universal moment happening everywhere at once. What is happening for you right now might not yet exist for a galaxy billions of light years away. In this vast cosmic web, every point experiences its own rhythm, its own pulse of time. When we gaze at the night sky, we are not seeing the universe as it is, but as it was. Every star, every galaxy shines with light that left long ago. Some photons began their journey when dinosaurs walked the Earth. Others when the first stars were born. The farther we look, the deeper into the past we travel. Each glimpse of starlight, a message from a different chapter of the universe's timeline. We live surrounded by ancient ghosts of light, watching a cosmic movie that began billions of years before we arrived. And yet, to the universe, it is all happening, still unfolding in its own scattered moments. The past, present, and future are not separate. They are woven together into one continuous fabric, space-time. Physicists describe this fabric as a four-dimensional continuum where space and time are inseparable. Mass and energy tell this fabric how to curve, and that curvature tells matter how to move, and how to experience time. You are not moving through time, you are moving with it, carried like a leaf in a current that shifts and swirls around every star. It's strange to think that the ticking of a clock or the beat of a heart depends on gravity. That in a deeper sense, time is not absolute. It is personal. Your every second is unique, bound to your position in space, your velocity, your energy. Even right now, the time flowing through you is not quite the same as the time flowing through the stars you see tonight. Perhaps that is why time feels so fragile. It cannot be seen or touched, only felt as motion, change, and memory. We measure it with machines, but we experience it through life itself, through aging, through love, through moments we wish could last forever. And maybe that human feeling, the ache of impermanence, is our way of sensing relativity in its most personal form. Scientists once dreamed of reversing time, of finding ways to move backward along its path. But as far as we know, the universe only flows forward. Entropy rising, energy dispersing, stars burning out. The arrow of time points toward greater disorder, toward the future. Yet, even within that unstoppable current, there are eddies, regions where gravity slows the flow, preserving ancient structures and moments longer than they should last. In the dense hearts of galaxies, time crawls. In the emptiness between them, it races. The cosmos is not one river, but billions, each flowing at its own pace. And so, the next time you stare into the night, remember this. You are not looking at the stars as they are, you are looking at time itself. Each point of light is a different era, a different heartbeat of the universe shining together across ages. You are seeing billions of moments at once, stitched into a single sky. Time, then, is not the ticking of seconds. It is the grand pulse of creation. The rise and fall of galaxies, the life and death of stars, the slow cooling of everything that has ever been. We are threads woven through that tapestry, aware for only a brief flicker, yet part of its eternal rhythm. Close your eyes and breathe. The seconds you feel passing are not lost. They are exchanged. Every heartbeat, every breath, every thought adds a note to the symphony of time that stretches across the cosmos. And in that endless score, your life, small as it may seem, is one of its most intricate melodies. As the universe expands, light stretches with it. Every beam that leaves a distant galaxy begins its journey as a brilliant wave of energy, short, sharp, and vibrant. But as it crosses the widening fabric of space, its wavelength grows longer, its color softens, and its energy fades. This transformation is called redshift. It is one of the universe's quietest signatures, a gentle stretching of light that records the history of cosmic expansion itself. When astronomers observe distant galaxies, they find their light shifted toward red, the longer end of the spectrum. The farther away the galaxy, the greater the redshift, meaning it has traveled longer through an expanding universe. Every photon becomes a witness, carrying with it the fingerprint of how much the cosmos has stretched since the moment it began its journey. This discovery was one of the most profound in science. In the early 20th century, Edwin Hubble studied the light from galaxies and found something astonishing. Nearly all of them were moving away from us, their light stretched by motion and by space itself. The farther a galaxy was, the faster it seemed to recede. From this, Hubble realized the universe was not static, but expanding, growing like a living organism, carrying galaxies outward in all directions. The redshift of light is, in essence, the universe's time machine. By studying it, scientists can determine not only how far away a galaxy is, but how long ago its light was released. When we look deep into the night sky, we are gazing back through cosmic time. Some of the light we see tonight left its home billions of years before Earth even formed. It crossed eons of expansion, stretching with every heartbeat of the universe, until finally, gently, it reached our eyes. To the human eye, the colors may seem simple: red, blue, white. But to astronomers, every hue holds a story. A bluer light means a galaxy is moving toward us. Its waves compress like the sound of a passing train. A redder light means it is moving away, its waves drawn out by distance and time. Together, these colors form a cosmic symphony, a visual music that tells us where we are in the flow of the expanding cosmos. This stretching of light also means that the universe's earliest glow, once bright and blazing, now lies beyond human sight. The ancient fire of the Big Bang has cooled, its light stretched so far that it now exists as microwave radiation. Invisible, faint, and cold, it still fills the sky, wrapping around Earth like a ghostly echo. We call it the cosmic microwave background, and it is the oldest light we can ever see. A redshift so immense that it carries us back to the first few 100,000 years of existence. It is humbling to realize that even light, the fastest thing in the universe, cannot escape the slow hand of time. As space expands, it stretches. As galaxies move apart, it grows weary. Each photon that reaches us has been on a pilgrimage through a changing cosmos, one that will continue to grow long after we are gone. Through redshift, astronomers have mapped the universe's entire history. They can measure how fast galaxies recede, estimate the age of the cosmos, and even glimpse its future. Because redshift is not only a record of distance, it is a measure of destiny. It tells us that the universe will continue to expand, that galaxies will drift further apart, and that in billions of years the night sky will grow darker as distant stars fade beyond the reach of light. Imagine standing on some far future world, beneath a sky emptied of galaxies. The stars we see now will be gone. Their light stretched too far to detect. The cosmic background will fade into silence. To those future observers, the universe will seem still and alone, unaware that beyond their horizon, space continues its endless growth. We are among the lucky few who live in this era, a time when the universe still glows, when light from its beginning still whispers across the dark. Even now, the expansion accelerates. A mysterious force called dark energy is pushing space apart faster than ever before. Because of it, light from distant galaxies redshifts at an increasing rate, its wavelength growing so long that it eventually fades into invisibility. In the far future, only the nearest stars and galaxies will remain visible. The rest will drift away into eternal red, into silence. But there is a kind of beauty in this fate. Redshift is not only a symbol of loss, but of connection. A reminder that every particle of light we see has shared a journey with the universe itself. To see redshift is to witness the heartbeat of creation, to glimpse how even light, the essence of energy, is woven into the rhythm of space-time. And perhaps that's why the night sky feels so alive, because each ray of light that touches your eyes tonight has been stretched, softened, and shaped by billions of years of expansion. It has drifted through the rise and fall of galaxies, through the forming of stars, through the birth of worlds. It carries the story of everything, from the first atoms to this quiet moment, right here, beneath your gaze. So when you close your eyes, imagine those waves still traveling, stretching gently through the dark, their color deepening, their rhythm slowing until they fade beyond sight, but never truly vanish. For even when light slips into red, its story continues. A soft, endless echo of the universe remembering itself. Not all light that travels through the cosmos belongs to the world we can see. Beyond the spectrum of human vision lies an ocean of invisible radiation. Wavelengths too short or too long for our eyes to detect. Ultraviolet light, X-rays, radio waves, and infrared glows all move silently through the dark, weaving the unseen story of the universe. In the early days of astronomy, humans looked upward and believed the stars they saw were all that existed. But then came the age of invisible light. With the invention of telescopes that could sense wavelengths beyond our own, we discovered that the cosmos shines in far more ways than we ever imagined. Every type of light reveals a different layer of the universe, like peeling back veils from a cosmic painting that has always been there, waiting to be seen. Ultraviolet light, for instance, exposes the raw power of star formation. In the hidden glow beyond violet, newborn stars blaze with energy so intense it tears apart surrounding gas clouds, carving luminous caverns in space. Galaxies seen in ultraviolet shimmer like living organisms, pulsing with regions of birth and destruction, where light is not gentle but fierce and unfiltered. These wavelengths tell us where the youngest stars live, where cosmic storms ignite, and where the future of starlight begins. Infrared light, on the other hand, reveals what is cold and hidden. Dust clouds that appear dark in visible light shine softly in infrared, like glowing embers buried beneath ash. Through infrared telescopes, astronomers can peer into star nurseries cloaked in darkness, seeing newborn suns cradled in the gas that once hid them. Infrared light also carries the warmth of distant planets, the glow of asteroids, and even the faint heat left behind by the Big Bang itself. It is the light of memory, the gentle echo of things that still radiate long after their brightness has faded. Then there are radio waves, vast and low in frequency, spreading across space like cosmic whispers. In radio vision, the universe is transformed. Quiet galaxies suddenly burst into shape. Giant jets of plasma stretch thousands of light years from the hearts of galaxies where supermassive black holes feed. Invisible magnetic fields trace intricate patterns around them, sculpting shapes that could never be seen by eye. It is through radio telescopes that we have found pulsars, spinning neutron stars that beam energy in perfect rhythm, ticking like the heartbeat of time itself. The quietest parts of the night sky glow faintly in radio light. This faint hum, known as the cosmic radio background, is a whisper from the universe's youth, a relic of a time when galaxies were still forming and black holes were young. When scientists tune their instruments between frequencies, part of that static, that hiss of noise, is the echo of creation. Every radio signal carries fragments of stories billions of years old. Beyond even these lies the realm of X-rays and gamma rays, where energy becomes violent and extreme. Here we find the marks of cosmic collisions, neutron stars crashing, black holes devouring matter, and the universe expressing itself through flashes of unimaginable intensity. These bursts, though brief, light up detectors across Earth, revealing moments of pure transformation where entire suns collapse in seconds. They are the fireworks of existence, rare and fleeting, but powerful enough to reshape galaxies. When we combine all these forms of light, a fuller picture emerges. The universe seen through multiple wavelengths is not calm or static. It is alive, dynamic, and endlessly expressive. Some regions blaze fiercely in ultraviolet and X-rays. Others glow softly in infrared and radio. Together, they form a grand cosmic symphony, with each wavelength playing its own melody, harmonizing across the void. This hidden light has also revealed secrets of our own home, our Milky Way. Infrared eyes have shown us the dense web of dust that winds through its spiral arms. Radio maps have traced the galactic magnetic fields threading through interstellar space like invisible rivers. And ultraviolet detectors have captured the ghostly halos that surround our galaxy, glowing softly with scattered starlight. The Milky Way, once just a band of light across the sky, is now a vast, multi-dimensional structure, radiant in ways we cannot see but can now imagine. Each type of light is like a different sense, expanding our perception of existence. Where our eyes see darkness, instruments reveal galaxies. Where we perceive silence, the cosmos hums with frequency. The night sky is not empty. It is overflowing with voices beyond hearing, colors beyond sight, energies beyond comprehension. If you could see in all wavelengths at once, the universe would no longer be black. It would glow with layers of fire and frost, radiation and resonance, a cathedral of light built over billions of years. Every photon, visible or not, carries a piece of that beauty, whispering across time. And as you rest tonight, remember that even the darkness around you is not truly dark. It is filled with invisible light, faint glows, ancient echoes, and waves of energy passing through your body every moment. You are bathed in the afterglow of creation, wrapped in the same radiation that connects stars, galaxies, and life itself. To see the unseen is to understand that the universe hides nothing, only waits for us to open our eyes wide enough to perceive it. Every second, the universe passes through us, unseen, untouched, but constant. Streams of invisible particles called neutrinos race through your body, through the ground beneath you, and out the other side of Earth. They come from the heart of stars, from exploding supernovae, and from the moment of the Big Bang itself. Trillions pass through you every second, yet you will never feel even one. They are the ghosts of the cosmos, weightless messengers from the most energetic events in existence. Neutrinos are born wherever nuclear reactions occur. Inside our sun, in the fiery fusion that turns hydrogen into helium, neutrinos are created and released at nearly the speed of light. They slip effortlessly through walls, through planets, through entire galaxies, almost never stopping. For every beam of sunlight that warms your skin, countless neutrinos have already passed through you, silent, invisible, unstoppable. Unlike light, neutrinos do not bounce, reflect, or scatter. They carry information that light cannot, about the cores of stars, the hearts of explosions, and the birthplaces of elements. When a massive star dies in a supernova, most of its energy, nearly 99%, escapes not as light, but as a flood of neutrinos. They rush outward, reaching the universe long before the explosion's glow becomes visible. To detect them is to feel the faint pulse of creation itself, carried in a storm of ghostly travelers that never rest. For decades, scientists doubted they could ever capture one. Neutrinos are so elusive that billions pass through a solid wall of lead without colliding with even a single atom. But patience and creativity prevailed. Deep underground, where cosmic rays cannot interfere, enormous detectors were built, giant tanks filled with pure water or heavy liquid, surrounded by sensors sensitive enough to catch the faintest flashes of light. When a rare neutrino interacts with matter, it leaves behind a tiny spark, a brief, shimmering signature in the dark. In these quiet underground halls, we have begun to listen to the universe in a new way. Each detected neutrino is a whisper from something distant, a supernova, a quasar, or perhaps the remnants of the Big Bang itself. The largest of these observatories, like Super Kamiokande in Japan or Ice Cube buried beneath the Antarctic ice, act as ears pressed to the heart of the cosmos. Through them, we hear the soundless symphony of the stars. But neutrinos are not the only travelers that reach us from beyond. High-energy cosmic rays, protons and atomic nuclei accelerated to nearly light speed, constantly bombard Earth's atmosphere. Born in violent places like supernova remnants, pulsars, and black hole jets, they carry the raw energy of destruction and creation. When they strike the upper air, they collide with atoms and create cascades of secondary particles that shower down toward the surface. Every second, these ancient messengers rain upon us, tiny reminders that the universe is alive, active, and endlessly in motion. Most cosmic rays are harmless, their energy absorbed by the atmosphere long before they reach the ground. Yet among them are a few with unimaginable power, particles so energetic that they outshine anything produced in human laboratories. One such cosmic ray, detected in 1991, carried as much kinetic energy as a baseball thrown by a professional pitcher, yet it was smaller than a single atom. Its source remains unknown. Was it flung from a dying galaxy? A jet from a supermassive black hole? Or perhaps something beyond our understanding? Each of these particles is a mystery, a question written in motion. Cosmic rays and neutrinos reveal a universe that is far from still. Even in the quietest night, waves of energy, particles, and radiation flow through us. The cosmos is not empty. It is alive with motion, pulsing with invisible rivers that cross light years to reach this small blue world. We are constantly touched by ancient messengers, fragments of long vanished stars still traveling through space, still carrying their stories. To imagine this is to realize how deeply we are connected to the universe. Every breath you take is filled with particles forged in dying suns. Every moment, you are struck by neutrinos born from explosions billions of years ago. You are not outside the cosmos. You are within it, part of its endless exchange of energy and matter. And yet, despite their abundance, neutrinos remain one of science's greatest enigmas. They have mass, but so little that it challenges the laws of physics themselves. They oscillate between types as they travel. shifting identities in ways no other particle does. Their behavior suggests that the universe may hide dimensions and forces still unseen, hints of deeper truths that remain just beyond our reach. In studying them, we are not only exploring particles, we are exploring time. Some neutrinos we detect today may have begun their journey in the first seconds after the Big Bang. They have traveled across the entire history of the cosmos to reach us, carrying the faintest echoes of its birth. They are relics of the beginning, still moving, still whispering through matter, still telling the same story they began more than 13 billion years ago. So tonight, as you rest, think of the countless invisible travelers moving through you. Particles from the sun, from ancient supernovae, from the very dawn of creation. You are surrounded by the memory of the universe, touched by the remnants of its earliest fire, connected to every star that has ever burned. The cosmos, in its infinite silence, is still speaking, and you, right now, are listening with every atom of your being. Even the emptiest space is never truly empty. For centuries, scientists imagined the vacuum of space as absolute nothingness, a silent void between the stars. But in the realm of quantum physics, silence is an illusion. Even in total darkness, the universe hums. At the smallest scales imaginable, space seethes with invisible energy. Particles and antiparticles flicker into existence, collide, and vanish again, borrowing energy for a heartbeat before returning it to the void. This restless activity is called quantum fluctuation. It happens everywhere, all the time, even in the quiet between atoms, even in the vast emptiness between galaxies. To the human eye, this energy is imperceptible, but to the laws of physics, it's everything. These fleeting virtual particles give rise to magnetic fields, pressure, and gravity itself. They are the foundation from which all reality emerges, tiny pulses of being and unbeing, weaving the very texture of space-time. Imagine the universe not as an empty canvas, but as an ocean, not of water, but of potential. Ripples form constantly across its surface, each one a momentary possibility. Sometimes those ripples grow strong enough to shape the cosmos itself. Scientists believe that the galaxies, stars, and planets we see today were seeded by quantum fluctuations that occurred in the universe's first instant. Tiny irregularities in that newborn energy field were stretched by cosmic inflation, magnified into the great structures of the modern universe. In a way, everything that exists, from your heartbeat to the light of distant galaxies, began as a whisper in the quantum foam. Creation, it seems, does not begin with something. It begins with almost nothing. Quantum fluctuations also mean that emptiness is never still. The vacuum constantly generates minute amounts of energy, known as zero-point energy, which cannot be removed or reduced. Even if you took away every particle, every atom, every photon, the vacuum would still vibrate faintly with life. It is this faint hum that scientists believe gives rise to mysterious forces like dark energy, the invisible push causing the universe to expand faster and faster. So when we say space is expanding, we are really describing this dance of energy and emptiness, the quantum field stretching, breathing, and evolving. The cosmos is not frozen. It is alive with fluctuations that ripple through time. At this scale, the rules of reality blur. Particles can appear on one side of a barrier and reappear on the other without crossing the space between, a phenomenon known as quantum tunneling. An electron can exist in multiple states at once until it is observed, collapsing into one reality the moment it is seen. This strange behavior doesn't only occur in laboratories. It is the underlying mechanism of the entire universe. Every atom in your body, every flash of light, every chemical bond, all depend on these quantum principles. It's as if the universe itself is constantly making choices, collapsing possibilities into reality with every passing moment. And we, conscious beings, are part of that unfolding process. witnesses and participants in a grand quantum play. Even black holes, those cosmic abysses, are not immune to this hidden activity. Stephen Hawking's groundbreaking work revealed that quantum fluctuations near the event horizon could create Hawking radiation, particles that slowly leak away from the black hole's edge. Over unimaginable timescales, this radiation will cause black holes to evaporate, dissolving into light and energy until nothing remains. Thus, even the darkest, most permanent structures in the universe will one day fade, undone by the same quantum hum that created them. This cycle, creation, transformation, dissolution, is the universe's quiet rhythm. From the smallest particles to the largest galaxies, everything exists in flux. Every fluctuation is a breath, every field a heartbeat, every atom a brief arrangement of probability that will one day change again. It's strange, isn't it? That beneath the vast stillness of the stars lies something so restless, so alive. We look up and see silence, but the silence is filled with trembling. We think of nothingness as absence, but it is presence, infinite, subtle, and constant. If you could magnify the vacuum 1 billion times, you would not see emptiness. You would see waves upon waves of energy flickering, forming and vanishing faster than any clock could measure. It would look less like a void and more like a living storm. A storm that has no beginning and no end. And in that storm, everything is connected. The atom in your hand is tied by invisible threads to the vacuum that birthed the stars. The same fluctuations that gave rise to galaxies also hum within you. You are not separate from the void. You are made of it, animated by its constant vibration. The universe breathes through quantum motion. Even as you sleep, particles shimmer in and out of being within every cell of your body. Reality is not solid. It is a rhythm, a song that never stops playing. And though we cannot hear it, we feel it, in the way light moves, in the way time passes, in the quiet pulse that keeps everything alive. So when you close your eyes tonight, know this: you are floating not in emptiness, but in energy, the same restless ocean that has existed since the dawn of time. You are part of the hum beneath creation, a pattern written in the language of chance and light. And in the deepest silence, where nothing seems to move, the universe is still singing, softly, endlessly, the song of being. In the beginning, there was no light, no stars, no galaxies, no time as we know it. All of existence was compressed into a single, unimaginably dense point. Then, in an instant, it expanded, not into space, but as space itself. This event, known as the Big Bang, marks the moment the universe began its long and luminous story. It was not an explosion in the traditional sense. There was no outside for it to explode into. Instead, it was the rapid stretching of space-time, carrying with it the energy and matter that would become everything we know. In its first second, the universe grew faster than light, expanding from smaller than an atom to larger than a galaxy. Physicists call this moment cosmic inflation, the universe's first breath. As it expanded, it cooled. Energy condensed into particles, protons, neutrons, and electrons. After just a few minutes, the first atomic nuclei began to form, mostly hydrogen and helium, the building blocks of future stars. For hundreds of thousands of years, the universe remained a dense fog of light and matter, glowing like an endless sea of fire. Then, as it cooled further, atoms captured their electrons, and the fog cleared. Light, at last, could travel freely, and the cosmos became transparent. That ancient light still fills the universe today. We call it the cosmic microwave background, the faint afterglow of creation. It is the oldest light we can ever see, the universe's first visible memory, stretched and cooled over billions of years into soft microwaves. When astronomers map this background, they see not perfection, but tiny ripples. minute variations in temperature and density. Those ripples are the fingerprints of everything that would follow: galaxies, stars, planets, and life itself. From those faint irregularities, gravity began its slow and patient work. Over millions of years, slightly denser regions pulled in more matter, growing into vast clouds of gas. These clouds, collapsing under their own weight, gave birth to the first stars. Immense, brilliant giants that burned hot and died young. Their light pierced the cosmic darkness, ending the long night that followed the Big Bang. The first stars were unlike anything that exists today. Composed only of hydrogen and helium, they blazed with pure, fierce energy. Some were hundreds of times the mass of our sun, and their lives were short, just a few million years before exploding as titanic supernovae. These explosions forged the first heavy elements: carbon, oxygen, iron, scattering them into space, seeding the raw materials for future generations of stars. From these ashes, galaxies began to form. Gravity gathered gas and dust into rotating disks, where new stars continued to ignite. The first galaxies were small, irregular, and chaotic. Cosmic pioneers in a universe still finding its balance. Over billions of years, they merged, collided, and evolved into the vast spiral and elliptical galaxies we see today. Our own Milky Way is one of them, a structure born from countless mergers, carrying the memory of every collision within its stars. Every atom in your body, every grain of sand on Earth, every drop of water in the sea, all trace their origin back to that first generation of stars. The calcium in your bones, the oxygen in your breath, the iron in your blood, forged in stellar furnaces billions of years ago. The Big Bang gave the universe its beginning, but the stars gave it form, color, and life. You are, in the most literal sense, made of the universe's memory, the living echo of the Big Bang. Scientists have spent decades piecing together this story, measuring the cosmic background, the redshift of galaxies, and the abundance of elements. Every observation confirms the same narrative. The universe has been expanding and cooling for nearly 14 billion years. And though it began in unimaginable heat and density, it has grown into a cosmos of balance and structure. Galaxies drifting like luminous islands across an ocean of time. The Big Bang was not chaos. It was order waiting to unfold. It set the rhythm for everything: the speed of light, the pull of gravity, the strength of forces that hold atoms together. Had any of these constants been slightly different, the universe might have collapsed or expanded too quickly for stars to form. Instead, it balanced perfectly, allowing complexity to bloom. It is as if the universe from its very first moment was tuned for beauty. And yet, the Big Bang was not the beginning of everything. Not quite. It was the beginning of our universe, but perhaps not the only one. Some theories suggest that inflation could spawn countless universes, each with its own laws of physics. A cosmic multiverse where creation happens endlessly, like bubbles forming in a vast sea of possibility. If true, our entire cosmos might be just one note in an infinite symphony. A single verse in the eternal song of being. But even if there are others, this one, our universe, is enough to fill eternity with wonder. Because from that one act of expansion, from a single instant of light, came everything. Stars, galaxies, planets, oceans, and consciousness. A story written in heat and gravity, continuing now through you. A being of atoms forged in fire, capable of looking back and saying, "I was there at the beginning." Tonight, as you listen to the quiet of space, imagine that first spark. A universe smaller than a seed, expanding, glowing, awakening. Everything that will ever be already contained within it, waiting to unfold. From that single breath came time, light, and life itself. The universe is still expanding, still breathing, And you, right now, are part of that same eternal exhalation. After the Big Bang, the universe began to settle into form. But its work was far from finished. The first stars, those immense beacons of light, came and went in blazing cycles of birth and destruction. Each explosion scattered the ingredients for new worlds, filling the young cosmos with elements that would one day build planets, oceans, and living things. As time moved forward, the universe entered what scientists call the cosmic dawn, an age when light returned to fill the dark. The first galaxies gathered, shaped by invisible threads of gravity woven through the cosmic web. These filaments, made of dark matter, pulled gas and dust into clusters, forming luminous islands across the expanding sea of space. From those small beginnings came the grand spirals and giant ellipticals that now shine across the night sky. Inside these galaxies, the process of creation never stopped. Stars continued to form, living their long lives in cycles of fusion and renewal. Some burned gently for billions of years. Others lived fast and died young, releasing bursts of energy powerful enough to outshine entire galaxies for brief moments. The death of one generation became the birth of the next, a galactic heartbeat that still continues today. At the centers of many of these galaxies, something extraordinary formed: supermassive black holes. They began as smaller remnants of massive stars, but as eons passed, they grew by consuming gas, dust, and even other stars. Each one became a gravitational anchor, shaping its host galaxy like a silent conductor guiding a cosmic symphony. Our own Milky Way has one, Sagittarius A, more than 4 million times the mass of the Sun. Invisible, yet its presence defines the motion of every star within the galactic core. When these colossal black holes feed, they release energy that can travel across millions of light years. Streams of plasma shoot outward from their poles, forming jets that glow brightly in radio and X-ray light. These relativistic jets are so powerful they can sculpt the shape of an entire galaxy, regulating how new stars form by heating or dispersing the surrounding gas. In this way, black holes, once thought to be destroyers, are also creators, maintaining balance in the universe through both chaos and order. The regions around these black holes are some of the most extreme environments in existence. Matter spirals inward at nearly the speed of light, heating to millions of degrees before vanishing beyond the event horizon. As it falls, it releases bursts of radiation, flickers of energy that can be seen from across the cosmos. Astronomers call this glowing halo an accretion disk, a luminous farewell from matter before it disappears forever. And yet, not all black holes are massive. Some are small, just a few times the mass of our Sun, formed from the collapse of dying stars. These stellar black holes drift silently through space, often paired with companion stars whose material they slowly draw away. Others, scientists believe, may be primordial. Ancient black holes born in the earliest moments after the Big Bang, as the universe's first fluctuations collapsed under their own gravity. If they exist, they could be scattered everywhere, tiny relics of the universe's infancy. Older than any star, in the deepest reaches of space, black holes sometimes collide. When they do, they merge into larger ones, sending out gravitational waves that ripple through the fabric of space-time itself. These ripples travel for billions of years, stretching and compressing the universe in ways almost imperceptible. When they reach Earth, they cause detectors to shiver, a vibration smaller than the width of an atom, yet powerful enough to confirm that space itself can move. It is through these cosmic quakes that we now listen to the heartbeat of the universe. Every collision, every jet, every flicker of radiation tells us something profound about balance. For every force of creation, there exists one of destruction. For every burst of light, a shadow waiting beyond. But in the grand design of the cosmos, even destruction has purpose. When stars die, they scatter the seeds of life. When galaxies collide, they create new ones. And when black holes merge, they reshape space-time, sculpting the very fabric upon which new stories will unfold. To think of the universe in this way is to see it not as chaos, but as rhythm, an eternal cycle of energy moving between forms, never lost, never wasted. The death of one thing becomes the foundation for another. Even the darkness itself, the black holes, the empty voids, the silent spaces between galaxies, are not endings, but pauses between notes. In our own galaxy, this rhythm continues quietly. New stars ignite in the Orion Nebula, clusters of suns forming from swirls of cold gas. Old stars fade into red giants, shedding their outer layers into glowing clouds of color. In time, these remnants will cool, drift, and collapse again, feeding the next generation of stars. It is the same cycle that has been unfolding for billions of years, unbroken, unstoppable, eternal. So when you look at the night sky, you are seeing history written in light, galaxies colliding, black holes feeding, stars dying and being born, all at once. The universe may appear still, but it is alive, breathing, evolving. Each point of light is a moment frozen in time, and yet still connected to everything else through gravity, through energy, through memory. Even now, as you listen, new stars are forming in silence, new galaxies are colliding, and invisible waves are passing through you. The echoes of events that happened millions of years ago, continuing to ripple across space. In that sense, you are not just an observer of the universe, you are part of its ongoing story. The atoms in your body once shone as starlight, the calcium in your bones once fused inside a supernova, and the light in your eyes was born from the same cosmic fire that still burns among the galaxies. We are the continuation of the Big Bang, living fragments of an ancient explosion that never truly ended, still expanding, still glowing, still becoming. And though we may fade, the universe will carry our light forward, just as it has done for everything that ever was, and everything that will ever be. The story of the universe is not one of chaos alone. It is also a story of order, balance, and quiet design. Across billions of light years, galaxies gather into clusters. Clusters weave into filaments. And between them lie vast cosmic voids, enormous regions almost completely empty of matter. Together, they form what scientists call the cosmic web, a structure so immense that it stretches across the entire observable universe. Imagine a three-dimensional map of the cosmos. Galaxies are not scattered randomly, but arranged like pearls on invisible strings, tracing the lines of dark matter that bind them. These filaments stretch for hundreds of millions of light years, connecting clusters like bridges of light suspended in darkness. Between them, the voids expand, silent oceans where galaxies are few and space itself seems to rest. This web is not static. It grows and evolves as gravity pulls matter together and dark energy pushes space apart. Galaxies flow slowly along its filaments like droplets, following the contours of an invisible river. At the intersections of these filaments lie galaxy clusters, vast gravitational cities containing thousands of galaxies, each one home to billions of stars. Within these hubs, the cosmic web shines brightest, glowing with the collective light of countless suns. The largest of these clusters can span 10 million light years across, containing not only galaxies but hot plasma and dark matter halos so massive they bend the path of light itself. Gravitational lensing around such clusters allows astronomers to glimpse galaxies even farther away, faint reflections magnified by the warping of space-time. In this way, the structure of the universe acts as its own telescope, using gravity as a mirror. The cosmic web also reveals the hidden balance between gravity and expansion. Gravity pulls matter inward, drawing galaxies together. Dark energy pushes space outward, driving them apart. For billions of years, these opposing forces have shaped the rhythm of the universe, a delicate equilibrium that determines whether the cosmos will expand forever or collapse back upon itself. So far, expansion has the upper hand, and the web continues to stretch, its filaments thinning like strands of silk drawn across infinity. It's astonishing to think that from a few tiny ripples in the early universe, this intricate structure has emerged. Those faint fluctuations in the cosmic microwave background grew under gravity's influence into the vast architecture we see today. Walls of galaxies spanning unimaginable distances. Every spiral galaxy, every cluster, every star is part of this grand design, connected through invisible bonds of gravity. And yet, for all its size, the cosmic web is mostly empty. More than 90% of the universe is space where there are no galaxies at all, just faint wisps of hydrogen gas and the occasional wandering star. The universe, it seems, creates beauty not through abundance, but through balance. Its brilliance lies in the patterns formed between the voids, the tension between light and emptiness. Astronomers use massive computer simulations to recreate this web, starting from the conditions that existed just after the Big Bang. As the simulated universe evolves, it grows into something remarkably similar to what we observe. Threads of light forming clusters, dark matter shaping the scaffolding beneath it all. These simulations are like time machines, allowing scientists to witness billions of years of cosmic evolution in moments. They show us that the structure of the universe is not random. It is mathematical, almost musical in its symmetry. And though we often think of galaxies as the centers of everything, in truth, they are small notes in a much larger harmony. Each one spins, glows, and drifts in time with the grand cosmic rhythm, influenced by the pull of the web around it. In this vast interconnection, nothing is isolated. Every movement, every rotation, every collision echoes across the fabric of the universe. The cosmic web is the largest known structure in existence, yet it reflects patterns we see everywhere. The branching of neurons in the human brain, the roots of trees, the flow of rivers, all share a similar geometry. It's as though the universe repeats its design across scales, from the microscopic to the cosmic, weaving the same rhythm into every level of existence. The shape of thought, the growth of roots, the spread of galaxies, all follow the same quiet code. Perhaps that is the universe's greatest secret: repetition. Not monotony, but resonance. A structure so vast it echoes through everything, reminding us that connection is its most fundamental law. Galaxies and minds alike are networks, luminous nodes bound by invisible threads. We are not observers standing outside this web. We are part of it, stardust arranged into consciousness, the universe aware of its own pattern. When you gaze into the night sky, you are looking along one of those threads. Each star you see, each faint galaxy beyond, is part of the same vast network stretching beyond imagination. Between you and them lies space filled with invisible currents of gravity and time, flowing in silence. And within you, in the synapses of your brain, in the veins that carry your breath, the same pattern hums quietly, echoing the architecture of the cosmos. It is humbling to realize that our universe, in all its immensity, follows such simple beauty. Gravity draws, energy expands, and from their dance emerges a tapestry of stars and voids, matter and motion, existence and silence. And we, for a moment, have the privilege of seeing it, of understanding, even dimly, that we are part of the web that holds it all together. Every atom in your body was once scattered through this network, part of the same cosmic thread that shaped galaxies long before you were born. And when your atoms return to the stars, they will continue their journey through the web, woven once again into the infinite fabric of creation. In this way, Nothing is ever lost. The universe keeps all its stories, written not in words, but in the structure of light and gravity. To exist is to belong to that story, to be a single note in the eternal